Good morning, good afternoon, or good evening, depending on where you are in the world. We'd like to present to you part three, or actually, actually, I should put lesson three of the chapter. Was they have it as chapter, but it put lesson. So let's just put lesson. Lesson three of basic electronics, and for this topic, we're going to talk about capacitors and inductors. Okay, now when it comes to digital electronics, capacitors are almost a matter of insurance, providing short-term stories, or short-term stores of energy charge that improves the reliability of circuits. So here's our main purpose. Okay, our main purpose is to store energy temporarily in the circuits. Okay. In fact, the insulating layer between the conductive surfaces of the capacitor can just be air, although a capacitor using the air gap will be very low in fact. The value of a capacitor depends on the area of the conducting plate, how close they are together, and how good an insulator separates them. So the greater the area of the plates, I don't want to say so, but let's just say the greater the area of the plates and the smaller the distance between them, the greater the capacitance. Okay, capacitance is the ability to store charge, okay? Or the more it can charge it can store. Individual electrons do not flow through a capacitor, but they are on one side of the capacitor influence, those on the other. If you apply a voltage source like a battery, like a battery to a capacitor, then the plate of the capacitor stored to the positive supply of the battery will accumulate positive charge. So you can see the trend here: positive supply, so positive charge. Um, yeah, so positive supply of the battery will accumulate positive charge, and the electric field this generates will create a negative charge of equal magnitude on the opposite plate. Remember, you need plus and minus to get electricity. You can't just have pluses or minuses. Now, what we're talking about is charging and discharging a capacitor. As you can see, or just say, hold on, let me get this here. As you can imagine, or as you can see, the voltage across the capacitor does not increase linearly, but rather increases faster at first and then gradually tails off as the voltage across the capacitor gets closer to the battery voltage. The special type of very high capacitance capacitor is called a supercapacitor, and is sometimes used in place of a rechargeable battery for applications that require very rapid storage and release of energy. Great. Okay, now let me give you some characteristics about this, okay? A rechargeable battery uses a chemical reaction to generate electricity's capacitor to store a charge or stores charge directly. That is, a rechargeable battery must be charged and discharged over a period of minutes or hours. A capacitor can charge and discharge in fractions of a second. Now, the voltage across the capacitor falls off sharply as it starts to discharge, whereas the voltage across a battery stays relatively constant until most of the energy is used. Excuse me. Per unit size, battery can store around 10 times as much as energy as the best supercapacitor. So you see, that's what batteries are for, to store energy. Now let's talk about some types of capacitors here. I can just move this up a little bit. Now, First one is capacitor. So you have the first one, which are capacitors are less likely. Less reliable than resistors. If you exceed the voltage rating, you are likely to damage the insulating layer. Number two, electrolytic capacitors are used in electrolytic contained in an aluminum can. Aluminum can illustrate a very thin layer of oxide in a insulator. That is, creates a very thin layer of oxide as the insulator. That is, of course, to protect the this capacitor. These are especially prone to failure due to overvoltage and overly. Oops, I put a typo here. Over temperature or just age. So there's different reasons for it. Now, the fourth one is the polarized capacitors can have values around the overlap between the ranges of MLC and electrolytic capacitors. Okay, so that's what those are. Now, in terms of our voltage rating, you should remember that as soon as you get into the range of electrolytics, you'll be in a trade-off between capacitor size and voltage. Let's talk about its temperature rating. So we have voltage rating, we have a temperature rating. For the temperature rating, the ceramic and MLC capacitors are generally rated for a wide range of temperatures, but aluminum electrolytics are far less tolerant of high temperatures and are generally rated as as 80 or 105 degrees Celsius, not Fahrenheit, Celsius. Okay. Now ESR stands for equivalent series resistance. The temperature rating becomes important when the capacitors are being rapidly charged and discharged. Equivalent series resistance, or ESR. I probably should capitalize the E in this title. This is a type, specific type. So again, that's equivalent sized resistance. Okay, ESR. You can see two capacitors in parallel double up in the surface area of the conductive plates and therefore are correctly assumed to have the overall. Actually, let me just put this in the next page. Okay. You can see the two capacitors in parallel double up on the surface area of the conductive plates and therefore may correctly assume that the overall capacitance is the sum of the two capacitance. Right? Okay, plural, a singular plural. So one is capacitance and two is capacitance. And that would be the result of the capacitor's function. So if you want to have two capacitors in parallel, you need to, basically what you're going to do is you're going to connect two or more capacitors in a series, like one after the other. Now the total value of capacitance is, I need to roll that, calculated according to the following formula, which is interesting because it's similar to resistance. Remember from last lesson. So R total equals 1 over 1 C1 plus 1 over C2. So what you do is you say, okay, 1, and then you take the fractional addition of 1 over C1 plus 1 over C2. So it'll be 2 over C, basically, I believe. So we take whatever number 1 over this is. Let's say C1 is 6, C8 is 8. So 1 6 plus 1 8 equals. Okay, and then that's all divided by 1. That will give you your R total. Now, another notable thing is that you have capacitors that store huge amounts of energy. Now, they're also called supercapacitors. They're low voltage capacitors that have extremely high capacitance, meaning the ability to store a charge. They are primarily used as energy storage devices in situations that would otherwise use rechargeable batteries. They can have values up to the hundreds of F as in farads, that's the unit of measurement for capacitance. Now, supercapacitors also have the value of 500 degrees Fahrenheit or more that can be bought for just a few dollars to buy one of those supercapacitors. Sorry. Now, the maximum voltage for a supercapacitor is 2.7 volts. So for higher capacity use, capacitors can be placed in series with special conditioned circuitry to ensure that 2.7 volts limit is not exceeded as the bank of capacitors are charged. And this is the energy for the capacitance. That's E for energy equals capacitor times voltage squared divided by 2. Now remember that in an inductor, on the other hand, contrast, it basically, the simplest example I could use is just a coil of water. Oh, wire. Sorry, I'm tongue twisted here. So when we talk about DC, which is direct current, that would be in circuitry, not AC so much, but DC. It behaves just like any other length of wire and will have some resistance. But when AC flows through it, it starts to do something interesting, which is, let me get that colon there. A change in current in one direction and an inductor causes a change in voltage in the opposite direction. This effect is more marked with the higher the frequency of the AC flowing through the inductor. The net result of this is higher the frequency of the AC. Now, remember that inductor resists the flow of current. Okay, this is an important point to mention. So we have a formula for it. Let's say X equals 2 times pi times F times capital L. Now, that is, the reactance X of an inductor can be calculated by the formula, and these are all given. Lowercase f is the frequency of AC, capital L is the inductance of the inductor, and the inductance of the inductor will depend on how many turns of the wire as well that the wire is actually wrapped around. Now let me unbold that. Oh, wait, it's already bolded. What's the deal? Okay, weird. Excuse me. Inductors are used in switch power supplies, or SMPs, where they are pulsed at high frequency. And the frequency is up here. A type of inductor called a choke. Oops. Give me a second here. Just underline that. So the choke is designed to let DC pass while blocking the AC part of the signal. This prevents unwanted radio frequency noise from infiltrating a circuit. Then we have one more we should consider. It's called a transformer. Now, a transformer has primary coils and secondary coils. I keep saying coils. Coils. Primary coil and secondary coil. A primary coil is driven by AC. Say it's 110 voltage from the AC outlet. The transformer on the right is designed to step down AC outlet voltages to lower voltages. Now, it is used to be that if you wanted to power a low voltage DC appliance such as a radio transceiver from the AC outlet, then you would first use a transformer to drop the 100 volts AC at 60 hertz, which is the frequency. So when you talk about frequency, they're talking about electrons over the movement of electrons over time. Okay, it's kind of like speed. That's the frequency measured in hertz, and then of course, and then to say 9 volts. Okay, so you change it from 100. You change it from 100 volts to 9 volts. Okay. Now I'll go into next time about the AC to DC conversion, but first thing is what's called stepping down the voltage. Okay. Now you would rectify this and with a smoother the what? Why did I say smoother the low voltage? Okay, convert. Why did I say smoother? Oh, okay. You would then rectify and smoother the low voltage from AC into DC. I was trying to wondering what I was thinking at the time. Now, that's the next step. First is you step down the voltage because the DC circuits can only take a certain amount of voltage anyway. So step one is you step down the voltage from in the AC circuits, right? So basically like you plug it into the wall. It's 110 volts. You step it down to 9 volts. That's step one. Step two is you change the AC to DC. Now, keep in mind a couple of things. One, it's normally used as transformers are expensive and heavy items with iron and long lengths of copper winding wire. And number two, that transformers are still used as SMPS to operate a very high, very much higher frequency than 60 hertz. Now, operating at a high frequency, often 100s of kilohertz, so that would be thousands. So kilohertz is a 1,000 hertz, and then hundreds of that would be 100,000 hertz. Yeah, 100,000 hertz because it's 100 times 1,000 hertz. So hundreds of kilohertz allow the transformer to be much smaller and lighter than low frequency transformers while retaining good efficiency. Okay, so from an overly practical standpoint, that's basically what it is. Alright, so remember the formula here we have for an inductor. We have different things. Remember, we have the transformer, we have the inductor. Okay, and then we have super capacitors and capacitors. We have capacitors in parallel. We have our types of capacitors. And then charging and discharging a capacitor. And the storage of energy. Okay, so our two main things to remember is capacitors and inductors. Okay. All right. I believe that we'll conduct our lesson from what I've learned from basic electronics. And I wanted to share this with the world for anybody who would like to learn, especially if you want a refresher or it's the first time. So, I'd like to thank you for taking the time to watch this video, as you could be watching any other video, but you're watching this video and learning about basic electronics, so I do appreciate that. As it did provide value to you to learn basic electronics, what I'd like you to do is like you to please click like on the video. That way it'll be pushed through the algorithm and more people will be able to view it and see it. If you haven't already, please click the subscribe button. That way you'll have access to all the content on my channel, as I do have a variety of content on this channel. Also, if you haven't already, please click the bell button. That way you'll be notified of all the future videos that as they get published, so you won't miss any of my new videos. So I'd like to wish you a great day wherever you are in the world. Take care, and I'll certainly talk to you next time. Bye for now.